Hello friends, welcome. In this session, let's try to look at how to find out zeros of a biquadratic polynomial given two of its zeros. Now to start with, what's the meaning of zero of a polynomial? The zero of a polynomial is the value of x which will make the polynomial value equal to 0. So if the polynomial degree is 4, then we know that it will have 4 zeros. So let me write it down. We know that 3x to the power of 4 plus 6x cube minus 2x square minus 10x minus 5. This polynomial is nothing but equal to, if suppose let us say the zeros are alpha 1, alpha 2, alpha 3, alpha 4. We know that each of x minus alpha 1, x minus alpha 2, x minus alpha 3 and x minus alpha 4 are factors of the polynomial. So can I write it as equal to x minus alpha 1 into x minus alpha 2 into x minus alpha 3 into x minus alpha 4. Now we have been given two polynomials, so let us say this is alpha 1 and we will say this is alpha 2. We'll substitute, we will say x minus of root of 5 by 3 and multiply that with the x minus of minus, so can I say x plus root of 5 by 3 into x minus alpha 3 into x minus alpha 4. Now if I multiply, I will have a minus b into a plus b formula. So can I say x whole square minus root of 5 by 3 whole square, because we have the formula a minus b into a plus b equal to a minus b into a plus b is equal to a square minus b square. We have that formula with us. So what this becomes now, this becomes actually x square minus 5 divided by 3, nothing but equal to, if you take 1 by 3 out, you will have 1 by 3 into 3x square minus 5. So what is left out after that? We have x minus alpha 3, x minus alpha 4 still with us. So this needs to be multiplied with x minus alpha 3, x minus alpha 4. Same thing here, we are just simplifying the first two. We have x minus alpha 3, x minus alpha 4. Here also we have x minus alpha 3 and x minus alpha 4. Okay, now we have to find out alpha 3 and alpha 4. So why can't we take the polynomial and divide with 3x square minus 5? Then we should be able to find out a quadratic polynomial from which we can use splitting the middle terms and find out what is the value of alpha 3 and alpha 4. So let's do that step. So we'll take the polynomial 3x to the power of 4 plus 6x cube minus 2x square minus 10x minus 5, and we will divide that with 3x square minus 5, because we found that x minus alpha 1 into x minus alpha 2 is equal to 1 by 3 into 3x square minus 5. So we want to divide so that we can find out what is x minus alpha 3 into x minus alpha 4. So we'll do the division now. We have the process DRMS. First we have to divide, then we have to keep it on right side, then we will multiply, we will subtract. So the first part, divide leftmost terms. First you have to make sure both of them are in descending order. Yes, it is. Then descending order, then divide 3x to the power of 4 divided by 3x square, that's equal to x square. X square into 3x square is 3x to the power of 4. X square into minus 5 is minus 5x square, that is divide, then keep it on right, then multiply. We have done that. Now we have to subtract DRMS. So I'll have minus there and I have plus here. 3x to the power of 4 cancels, and the next step will be 6x cube plus 3x square minus 10x. Now If you again go for the next step D, 6x cube by 3x square is plus 2x. I have kept it on right side. Now I have to multiply 2x into 3x square is 6x cube. 2x into minus 5 is minus 10x. If you we subtract the last step we do, then these two will cancel out and we will have 3x square, and what is left out is minus 5. Now we can see 3x square minus 5, 3x square minus 5 one time. So I can say 1 into 3x square minus 5, and when you subtract them they will cancel and you will get remainder as 0. So now we know that x minus alpha 3 into x minus alpha 4 is equal to x square plus 2x plus 1. So this is nothing but equal to, we don't need to do the splitting the middle terms also here, because we know this is a square plus 2ab plus b square. I can directly write it as x plus 1 whole square. Now if x plus 1 whole square is x minus alpha 3 and x minus is equal to x minus alpha 3 into x minus alpha 4, obviously alpha 3 equal to alpha 4 equal to minus 1. So the zeros of the biquadratic polynomial are whatever is given to us, alpha 1, alpha 2, we found alpha 3 equal to alpha 4 equal to minus 1. Let's do one more example. Let's look at this problem. Find all the zeros of x to the power 4 minus 5x cube minus 15x square plus 79x minus 20 if two of its zeros are 2 plus root 3 and 2 minus root 3. So we know that if alpha 1, alpha 2, alpha 3, alpha 4 are zeros, then we know polynomial of x, p of x, is nothing but equal to x minus alpha 1 into x minus alpha 2 into x minus alpha 3 into x minus alpha 4. So what's the polynomial we have? X to the power of 4 minus 5x cube minus 15x square plus 79x minus 20 is nothing but equal to x minus alpha 1 into x minus alpha 2 into x minus alpha 3 into x minus alpha 4. Because it's a biquadratic polynomial, will have 4 zeros. We know alpha 1 is 2 plus root 3, alpha 2 is 2 minus root 3. So let's find out first what is x minus alpha 1 into x minus alpha 2. That's equal to x, we know that x square minus of alpha 1 plus alpha 2 into x plus alpha 1 alpha 2, or x square minus of alpha plus beta x into alpha beta. If you substitute that, we will have x square minus, you add 2 plus root 3 and 2 minus root 3, you will get 4x, and when you multiply them you will have a plus b into a minus b, a square minus b square. So 2 square minus root 3 square, that's nothing but equal to 1. How we got that? Let me write it down here. X square minus, first step is I have to add them, so 2 plus root 3 plus 2 minus root 3 into x plus 2 plus root 3 into 2 minus root 3. Here I have a square minus b square formula, that will give me 1. If I add them, these two will cancel. I will have x square minus 4x plus 1. So we know x minus alpha 1 into x minus alpha 2 is x square minus 4x plus 1. So to find out the product of x minus alpha 3 into x minus alpha 4, we'll go ahead with the polynomial and divide with the product of the first two linear polynomials, or the zero factors. That's nothing but x square minus 4x plus 1. So let's go ahead and do that. So we'll do the division part now. We'll use long division for that, and we'll write it as, we have x to the power of 4 minus 5x cube minus 15x square plus 79x minus 20 divided by x square minus, if I remember it's minus 4x and plus 1, because if you add them alpha plus beta it is 4 and alpha beta is nothing but right. Okay, now we have this. We have to find out the quadratic polynomial, which is product of x minus alpha 3 into x minus alpha 4. Then we can find out what is alpha 3 and alpha 4. For that we will again go back to DRMS. That's a long division for which I have kept a name so that some of the students felt it easy. You can have a look at that too. It's the same, just giving the steps of long division. First you have to divide. Before that you have to write them in descending order. D stands for descending order and also divide. You keep them in descending order, then divide the leftmost. X to the power 4 by x square is x square. You keep it on right side. We did that. Then you have to multiply. We will multiply now. X square into x square is x to the power 4 minus 4x cube. Then x square into plus 1 is x square. Now divide, write, multiply. After that we have to subtract. So let's subtract now. When I subtract, x to the power 4 cancels. I will have minus x cube minus 16x square plus 79x. Now again I have to go for one more round of DRMS. Divide. Minus x cube by x square is minus x. Then keep it on right side. We did that. Then we have to multiply. Minus x into x square is minus x cube. Minus x into minus 4x is plus 4x square. Minus x into plus 1 is minus x. Now we will again subtract. That's the last step of DRMS. So we will have minus 20x square, and you know whenever you subtract the signs will change. So this becomes plus 80x minus 20. One more round of DRMS. Divide. Minus 20x square by x square, that is minus 20. And what we have now, right side and multiply. We multiply minus 20x square plus 80x minus 20. When you subtract them, everything cancels out and you will get remainder as 0. So we know that x minus alpha 3 into x minus alpha 4 is x square minus x minus 20. Now I have to use splitting the middle terms to find out alpha 3 alpha 4. Here my sum is minus 1 and the product is minus 20. So I need to find out two numbers such that their subtraction is 1 and the product is 20. I'll go for minus 5 comma 4, which is nothing but x minus 5 into x plus 4 is equal to x square minus x minus 20. So by that you can say the other zeros are 5 comma minus 4. So the other two zeros are 5 comma minus 4. So if you split the middle terms, this is nothing but equal to x square minus x minus 20, that is x minus 5. You can check that into x plus 4. X square minus x minus 20. We know this how to do, so I am not detailing that. So you have x minus 5 into x plus 4. So 5 comma minus 4 are two of the zeros. Okay. Now sometimes there will be problems where they will not give the any zeros itself. Then how to do that? At that time we will check for p of 1 or p of minus 1 or p of 2, p of minus 2. We will find out one of the zeros. Then we will find out one of the factors of the polynomial. Then we will divide by that polynomial to get it into a quadratic polynomial, or we'll get it into cubic polynomial. Again we will apply one more time p of 1, p of minus 1. So we will do trial and error. We'll find out some of the factors. If it is a biquadratic, we'll try to find out two factors. Then we'll multiply the factors and divide by the polynomial so that we can find out the remaining two factors. So by finding out the factors, we can also find out the zeros of the polynomial. So that's couple of examples on how to find out the zeros of a biquadratic polynomial. The methodology is we have to find out the product of the given two zeros. From the zeros we'll find out the factors and take the product of them. Now divide this with the polynomial given to us. Then we'll get another quadratic polynomial. Now use splitting the middle terms and find out the remaining two zeros. So I'll catch you once again with another interesting example as part of polynomials. Thanks for your time and support. Bye for now.